Today we're going to talk about phase diagrams. A phase diagram is just reading a graph. If you can read a graph, you should be able to read a phase diagram. The only difference is a phase diagram actually tells you based upon what temperature and pressure you have, you'll be able to tell what state of matter your matter's actually in. Every single element and compound has its very own phase diagram because every pure substance can be a solid, a liquid, or a gas, depending on the pressure and the temperature. So the pressure increases as you go up this way, so you have 1 atm, 5.1, 72.9. And then the temperature increases as you go across this way, so you have negative 78.5, negative 56.7, and then 31. This is actually a phase diagram for carbon dioxide. So for carbon dioxide, it will tell us where a phase change happens, which actually happens on this straight line here. When you're on the straight line, you actually have both states of matter happening at the same time because that's your transition. So if you move from a solid to a gas, you go through a phase change. That phase change is sublimation. Or if you go from a gas and you go up this way and it turns into a liquid, you're going through condensation. So we can figure out if we increase or decrease our temperature, or if we increase or decrease our pressure, we can figure out what state of matter change is going to happen. There's a couple points on this that you do need to know about. Right here in the middle, you have what's called the triple point. Your triple point is actually where all three phases of matter hit together: solid, liquid, and gas. For your solid, liquid, and gas states of matter, whenever you're on the line, you're in transition between those two states of matter. So both are basically happening at the same time. At your triple point, that's where all three states of matter hit. So you have all three states of matter happening at the exact same time. If you look at your notes that you're recording down today with the sub, you'll actually see a video clip of somebody actually finding the triple point of water. And when you watch that video clip of somebody doing the triple point of water, you'll actually see solid ice. The liquid water will actually be there, but then you'll also have it boiling at the same time, meaning it's going from a liquid to a gas. So you'll see the solid, you'll see the gas, you'll see the liquid all happening. That happens at the triple point. The second point that you need to know about is up here. It's called the critical point. For your critical point, that just means that the temperatures and pressures are too high and too extreme that you can no longer have a gas or a liquid. Beyond this critical point, you have a different state of matter that's called a supercritical fluid. Again, if you go to your notes, there's a little explanation on what video clip to watch on YouTube, but it'll actually show you what a supercritical fluid looks like. Supercritical fluids, not liquids, not gases. It's a completely different state of matter, anywhere beyond that state of matter at a different pressure and temperature. So with your phase diagrams, the big takeaway, you have the solid, and it's always written in this part of the little Y. You have liquid, and you have gas. For your solid, liquid, and gas, at whatever temperature and pressure you are, you'll be able to figure out what state of matter you have. But then also it'll tell you what state of matter changes are happening if you, let's say you're right here and you increase the temperature, you're going from a solid to a liquid, so you're going to melt. Or let's say that you, decrease the pressure and you're right here. If you decrease the pressure, you're moving down this way because pressure's on this side. That means you're going to go from a liquid to a gas, so you're going through evaporation. So it will tell you state of matter changes. It'll tell you the state of matter based upon different temperatures and pressures.